means how fast something is changing over a period of time. Wow. My handwriting is horrible today, I'm sorry. So examples of things that are rate of change, growth could be a rate of change. You're growing 2 inches a month or something. You know, your hair grows, I think it's like 2 centimeters a month. That's a rate of change. And so rate of change is described as, I'm just going to call it rate of change, and that's described as the change in the range value divided by the change. Okay, maybe it's not me, maybe it's this pen. Okay, so it's change in range divided by the change in the domain, which is the change in y divided by the change in x. And in math, a triangle is the Greek letter delta, which equals change in. So that you don't actually have to write the word out, you can just put a delta, and anytime you put a delta x, delta y, delta z, it just means the change of it, how much it's changing. A rate of change in temperature, we're going to find, like, we first of all look at all of our temperature changes, and here's our time. So we have every 2 minutes we've taken the temperature. And we're going to assume, for our purposes at the moment, that this is a constant rate of change. And we can check that by subtracting every time to see if it's a constant rate of change. And I'm just going to cheat. So I have 143.6 minus 139.4. That's 4.2. And then so if I do 139.4 minus 133.1, 6.3. Ooh. I think I might have typed something wrong. Yeah, I typed this one wrong. That's what happened. $145.7. Let's just change that because it was meant to be a constant rate of change.
Doesn't that go the time out? Doesn't it go to 3, 4?
Oh, you're right, it does. Never mind then. Ugh, sorry. Thank you. This is what I get for not paying attention to what I'm doing. Okay, so we've got a difference in time of 2 minutes, 3 minutes, 3 minutes, and 4 minutes. A difference in temperature of 4.2, 6.3, 6.3, and not 126. 8.4 minutes, or 8.4 degrees. All right, so what's happening here is over time our temperature is cooling off in our solution. And so we want to find the rate of change. And what we're looking for is how many degrees per minute. So we're going to do the change in the range. Temperature is our range, and time is our domain. Now, how can you tell the difference between range and domain? Range is our dependent variable, and domain is our independent variable. And if you think about it, time is going to go no matter what's happening. time is going to pass. We cannot control that. Time just passes. So that is independent. It's just going to happen. The temperature depends on how much time has passed. So that's how you can tell which one is the range and which one is the domain. So I'm going to do change in the range over the change in the domain, and I can pick any one of these sets of points. So just for the heck of it, I'll pick this set. And so what I do is I subtract the second one minus the first one, second one minus the first one. So it's negative 6.3 over 3. So I'm going down 2.1 degrees per minute. You always want to do second minus first because that gives me that negative, and my temperature is going down, so it needs to be negative. Find rate of change using graph. So we've got a pool that's being filled with water, and we have a line that shows how much water is in the pool over time. So this is gallons here, and this is minutes. And I found 2 points on the graph for you and gave you the numbers. But if there weren't, you would come along and find 2 points on the graph and figure out which numbers they were. You could use this point, and this point would probably be the best points because they go through the crosses, or maybe this point would be good. So I'm going to do, to find the rate of change, I'll do 252 gallons minus 108 gallons over 7 minutes minus 3 minutes. So it's 144 gallons over 4 minutes. And this will reduce 72 over 2, which will reduce to 36 over 1. So it's 36 gallons per minute. In the real world, we don't always have constant rates of change. Even that temperature example where temperature cooling down from being on a heat source, even cooling and heating are not constant rates of change. So what happens is over time you have peaks and valleys, and change is not constant. So here's an example of CD sales versus MP3 sales and the percent. So in 2001, the percent of music sales that were from CDs was 89.2, and MP3s was 0.2%. And the rest of the 100% was probably like vinyl. Then you have in 2006, CDs have gone down to 85.6%, and MP3s have gone up 6.7%. But as you can see, things are kind of, peaking and going all over the place. The percentages are just sort of everywhere. So we want to find the average rate of change. So the average rate of change on the CDs, I'm going to take the last value minus the first value. So I'm going to get 89.2 minus 85.6, so 3.6 over 5. Sorry, negative 3.6. And if I divide that by 5, I get negative 0.72% per year. So CD sales went down almost 1% per year. That's my average. And for MP3s, I'll do 6.7 minus 0.2 over 2006 minus 2001. And I'm going to get 6.5 divided by 5. And that is going to give me 1.3% per year. So while CD sales went down 0.7% per year, MP3 sales went up 1.3% per year. And this has probably leapt quite a bit more since 2006. And this has probably plummeted a lot more. So rate of change and slope are the same thing. When we talk about rate of change, we're usually talking about real world things: temperature, growth, sales over time. Slope is the rate of change of a line. So as you have a line, and basically it's how far it's going up or down versus how far it's going right and left. It's also known as magnitude. And the reason I'm telling you that is because the symbol for slope is an M, and you might say, why on earth is slope an M? It makes no sense. There's not even an M in the word slope, but that's because slope is also magnitude, so they're the same thing. And it is the same thing. It's the change in y over the change in x, or we do y2 minus y1 over x2 minus x1 if we're given 2 points. And then the numbers on those points are x1, y1, and x2, y2. So we use ordered pairs or coordinates to determine the slope of a line. So we assign these points to x1, y1, x2. And it doesn't matter. I can say this is x1, y1, or I could say this point is x1, y1. That part doesn't matter. It's just that if I say this is x1, this has to be y1. If this is x2, this has to be y2. I can't say this is x1, y2. I have to keep the 1's together and the 2's together. But it doesn't matter which point is which. And then I plug them into my formula. So y2 is 5 minus y1, which is 3. x2 is 2 minus x1, which is negative 4. So I get 5 minus 3 over 2 minus negative 4, but whenever I minus a negative, it becomes a positive. So that's the same thing as 2 plus 4. So that's 2 over 6, which is 1/3. So my slope of the line that would pass through these 2 points is 1/3. What this means slope is also called rise over run. So this means I go up 1 and then over 3. So that tells me how, like, as I go along my line, I'm going to go up 1 over 3, up 1 over 3, up 1 over 3 to get from one point to the next. All right, so then the slope of the next line again, and I'm going to keep writing this formula in just because I want you guys to get really familiar with it. I can say x1, y1, x2, y2. So I have 5 minus negative 3 over 3 minus 1. So that ends up being 5 plus 3 over 2. So that's 8 over 2. So that's 4. Which is kind of the same thing as 4 over 1. So I'd actually be going up 4 over 1. So what I have here is if I looked at this line, I'd go up 1 and then over 1, 2, 3. So it would be a relatively flat line. Whereas if I look at this line, I'm going to go up 4 and then over 1 So you can see the slope of this line would be much steeper. Now these are not the actual graphs of these lines, but I'm just showing you the slope. This is a relatively flat line because the slope is a third, which is less than 1. This is a relatively steep line because the slope is 4, which is a higher number. Sometimes we're not given points, and we have to find the slope from a graph. And there are 2 ways to find the slope from the graph. There's the mathematical way, which is finding 2 points on the line and then plugging them into the formula and getting our value that way. Or there's the lazy way, which is by using the picture. My favorite way is the lazy way, but I'll show you both. Okay, so mathematically. Okay, so what I need to do is I go along my line and I find 2 perfect points. So perfect points are points that cross exactly through the crosshairs of your graph. And then I find the coordinates for these points. So that's 1, 2, 3, 4, -5, 1. So that's 1 point. And then the other point is 0, 1, 2, 3, 4, 5. 0, -5. That's a terrible 5. Okay, so that's my other point. And I can call this x1, y1, x2, y2, or vice versa. It doesn't really matter. But when I plug them in, I'm going to get 1 minus -5 over -5 minus 0. So I'm going to get 6 over -5. We don't usually leave negatives in the denominator though, so I'm just going to bring it out front. So it's -6/5. So that's my slope. So to get from one point to the next on this line, I'm going to go down 6 over 5. But maybe you don't want to do all that math. Well, the first step is the same. I'm still going to find 2 points that are perfect. Here we go, and here we go. But instead of worrying about what the coordinates are and plugging them into a formula, I'm just going to say, okay, to get from this point to that point, I can't take the line. I have to take, like, these are blocks, so these are roads, right? I can't cut through buildings. I have to take roads. So I go up 1, 2, 3. So I went up 3, so that makes it positive. And then I go over 1. This is my rise. This is my run. If I went up 3, I'm positive rise. So I'm rise over run.
I wasn't listening. What did you do?
I started here, and I had to go to here. So to get from here to here, I went up 3 over 1. Now you always want to start on the left and go to the right. And that'll tell you, because if you started here on the left and we went to the right, we would have gone down 6 first and then over 5, which would have told me -6. Right, so to go from here, we would have gone -6 and then over 5. If you go down first, your slope is negative. If you go up first, your slope is positive. But we never had to figure out which coordinates these were. We just went from one point to the next, and I said, oh, I have to walk 3 blocks, north and then 1 block east. Now, if you didn't go from left to right, let's say you started at 1 and you went to 3, you would have gone back 1 and then down 3, so you'd had 2 negatives, and 2 negatives make a positive, so you'd still get a positive number. If you have a line that goes this direction, that's positive slope. If you have a line that goes this direction, that's negative slope. If you have a line that's perfectly flat, that's a 0 slope. If you have a line that's perfectly straight up and down, that's undefined. slope. Okay, and that's because the change in x is 0, and you can't divide by 0, right? So if it's straight up and down, your slope is undefined. If it's completely flat, your slope is 0. If you go downward as you move from left to right, you're negative, and if you go upward as you move from left to right, you're positive. Okay, the slope-intercept form of equations is a very popular form of equations. You've probably seen this a million times. Y equals mx plus b, where m is my slope and b is my y-intercept, which is just where the line hits the y-axis. Okay. And this is the most useful format of an equation if you're talking about graphing. Very useful because this tells me my starting point, and this tells me my directions to go to the next point. So I start here, I use this to get to my next point, and I connect the dots. It's a very useful way to graph. But first we have to start with writing equations into that format. So if I am given an equation, I'm told to write an equation with a slope of negative 2/3 and a y-intercept of 6. I've been given m and b. So I simply plug those in. Negative 2/3 is m, 6 was b. Okay. Again, I'm given m and b, but this time b is 0. Well, I can write the plus 0 in there if I want to, but it doesn't really do anything. So I just leave it off. And here, if I have a slope of 0, well, what happens with 0 times x? I just get y equals negative 13. And if I were to graph this line, I have a 0 slope, so it's going to be a flat line at negative 13. We're not given all the information. We're not just given the slope and the y-intercept. So we're given a point and a slope. So we're through a point with a slope of negative 3/4. Now there's two ways to do this. You could draw the graph and find your y-intercept that way. Typically though, what you do is we use our slope-intercept form, and what we've been given is we've been given m, we've been given x, we've been given y. The only thing we don't have is b. So what I do is I plug y in, I plug m in, I plug x in, and I'm going to solve for b. Okay, 4 goes into 8 twice. So I get negative 5 is equal to negative 6 plus b. So because negative 3 times 2 gives me the negative 6. Then I will add 6 to both sides, and I get b is equal to 1. Okay. Did anybody need me? Okay, so if it divides evenly, like in this example, we do that. 4 goes into 8 twice, and then I multiply. 3 times 2 is 6. If it does not go in evenly, so let's say I have 3/4 times 5. 4 does not go into 5. When that happens, you just multiply these numbers. So I have 15 over 4, and then the denominator stays the same. Okay, so in this case I got b is equal to 1. So now I have b, I have m, so I plug those in. So here's my m and here's my b. And this is the equation of the line. This is the answer I was looking for. So, just one more example. again, y equals mx plus b. You guys will get so sick of hearing that. I've been given m, I've been given x, I've been given y. So I plug those in. So I have negative 5 is equal to negative 3 times negative 2 plus b. So negative 5 is equal to 6 plus b. So I'm going to subtract 6 from both sides, and so I get negative 11 is equal to b. So I plug in the m, and I plug in the b. So this line that goes through this point with that slope is negative 3x minus 11, which we'll go over that later. But if I'm given a point and another point, I first have to find slope. Then I use 1 point and m to find the line. Okay, so this one has two parts. So first I have to find the slope. So, oops, writing x's when I mean to write y's. y2 minus y1 over x2 minus x1. So that's going to be 7 minus negative 5 over 9 minus 3, which gives me 12 over 6, which is 2. So m is 2. Then use 1 point. 1 point. Yeah. So first I found m equals 2. So now I have m, and then I can pick either point. Do you guys want to use 3 and negative 5 or 9 and 7? Yeah, it doesn't matter. So any favorites? All right, then I'll just use this one. So that's x, that's y. So I have negative 5 is equal to 2 times 3 plus b. I'm going to get negative 11 again. So negative 5 is equal to 6 plus b. Subtract 6 from both sides, and I get negative 11 equals b. So my equation is y equals 2x minus 11. Okay, so just one more example. So I have 2 minus negative 2 over 1 minus negative 2. So that gives me 4 over 3. So my slope is 4/3. Then I do y equals mx plus b. I'm just going to use the positive one. Mostly because it made it nice because I'm multiplying by 1 since I have a fraction. So I get 2 equals 4/3 plus b. Now in order to subtract 4/3 from both sides, I need my 2 to be in terms of thirds. 2 is the same thing as 6/3. To figure that out, I multiply 2 times 3 because I want thirds, and that's what gave me the 6. So I have 6/3 is equal to 4/3 plus b. And then I subtract 4/3 from both sides. And then I run out of room, so I write it over here. Sorry about that. b is equal to 2/3. So my equation is y is equal to 4/3 x plus 2/3. Slope-intercept is the most popular, probably most useful, most functional method, but there's also another form of the equation, if you prefer it, called the point-slope form of the equation. And point-slope form is y minus y1 is equal to m times x minus x1, where y and x are letters, and y1 and x1 are numbers. they're a point. So if I'm given a point and a slope and I want to write it in point slope form, I would write y minus y1 is equal to m times x minus x1. So I do y minus -2 is equal to m times x minus -4. So that's y plus 2 is equal to, oops, sorry, I totally messed that up. I'm putting my slope where my x goes. Slope was -4, x was 6. And this is point slope form. You can leave it in point slope form. It's not very useful, but it is legitimate. Again, if I want to do point slope, it's y minus y1 is equal to m times x minus x1. So I get y minus 3 is equal to 1/2, which is m, times x minus 2. And I'm done. That is in point slope form. Now, some people like to start with point slope form to get to slope intercept. So we're just going to use each of these, and we're going to convert to slope intercept. So I'm going to put 2y equals mx plus b. Because sometimes you're asked to put something in slope intercept, but maybe you don't like to find b and you'd rather start with point slope form. So once I've found the point slope form, to convert it to y equals mx plus b form, I'm going to distribute that slope. -4. And then I subtract or add to get the y by itself. So as you can see, I found b at the same time. It takes away the step of having to then plug something in. It's all inclusive, and so that's why some people prefer it. So going from here, so I have y minus 3 is equal to 1/2 times x minus 2. I'm going to distribute that half. So I get y minus 3 is equal to 1/2 x minus 1. Add 3 to both sides. And I get y is equal to 1/2 x plus 2. So I can take that point slope form and convert it into y equals mx plus b very easily. Slope form, and I've just been given 2 points. Again, I have to first find m, then plug in. Now, in this instance, you end up with 2 different equations depending on which point you plug in. They're actually the same line, it's just they look different. So first I find m. So I get -3 minus 7 over 3 minus -2, which is -10 over 5, which is -2. So there's my slope, -2. And then I plug in, if I use the first point, I will get y minus 7 is equal to -2 times x plus 2. This is correct. This is with the first point. If I use the second point, I'll get y plus 3 is equal to -2 times x minus 3. This is also correct. I've just used the second point. So it doesn't matter which point you pick. They're both correct. And if I converted these through to y equals mx plus b format, I would get the same equation from both of them. It's just that when you're using point slope, the point you pick makes it look different. It's the same line, it just looks different. And every line has a million different equations because it depends, like you can pick any random point on there. But every line only has one slope-intercept form. Again, find m first. So I've got y2 minus y1 over x2 minus x1. So that's -4 plus 9 over -2. So that is -5/2.
Positive 5/2, right?
No, negative, because I've got the positive 9. So this would be positive 5 here and over -2. So here, this would become 5 over -2.
Yeah.
But we don't ever leave the negative in the bottom. We either bring it to the top or put it out front. It's just bad form.
What if you're graphing?
So
You all still want it up top. It's just in math, there are certain things that are considered improper. Not for any.
I have 4 cones that can go that way.
Right, this could go up 5 and back 2, but it's considered mathematically improper to put a negative in the denominator. So you always either bring it to the top or bring it to the front. Just like you don't have negative exponents unless you're using scientific notation. Negative exponents just aren't proper. It's like just randomly walking into somebody else's house that you don't know and eating all the food in their fridge. You just don't do it, right? The idea. Okay, so I found the slope. Would I mark you wrong if you left it like this? No, but I would probably put like a big circle around it, be like, don't move the negative up front, ew, because it's just like not done. So to put that into point slope, if I use the, if I use the first point, I'll have y plus 9 is equal to -5/2 times x minus 4. If I use the second point, I'll have y plus 4 is equal to -5/2 times x minus 2. And these are both, again, both correct. And I could show you that they're the same line if you want. Or you can just trust me that they're the same line and accept it. Does anybody need proof? Parallel and perpendicular lines. The symbol for parallel is, well, 2 parallel lines standing upright. And the symbol for perpendicular is 2 perpendicular lines or an upside down T. So this is the symbol for each of these, and you never have to write those words again, because now you can just put the symbols for them instead. Parallel lines. Parallel lines have identical slopes. So if I have line 1 and line 2, right? So the slope of line 1 will be equal to the slope of line 2. Perpendicular lines meet at a 90-degree angle. Okay, and the slopes are negative reciprocals. Okay, so if, let's say, the slope of line 1 was 2/3, just hypothetically, the slope of line 2 would be equal to -3/2. So 2/3 is perpendicular to -3/2. So 1 has to be flipped and negated in order to be perpendicular. So if you had whole numbers, 2 would be perpendicular to -1/2, or vice versa, -2 would be perpendicular to +1/2. Certain line or perpendicular to a certain line. First, I need to identify M. So M equals -2. So that's M1 of the line that I've been given. Parallel lines have the same slope. So I want my slopes to be equal. So I'm going to use the same slope. So I'm going to use -2. And here's my x and here's my y. So I'm going to plug them into y equals mx plus b, or you could use the point slope format if you want. I'll do that on the next one just to be even. So I have -1 is equal to -2 times -1 plus b. So I get -1 is equal to 2 plus b. I subtract 2 from both sides, and I get -3 is equal to b. So my equation of the line parallel to this line is going to be -2x minus 3. And if I graphed both these lines, they'd run parallel to each other, like train tracks. Now, if I'm doing perpendicular, I still have to identify the slope. That's M1. M2 is not going to be equal. It's going to be the negative reciprocal. So I had -3/2, so the slope I want to use is +2/3. And then again, this is x and y. So they'll cross, yeah. So then what will happen is, again, I could use the slope intercept, but in this case, I'm going to use point slope just to show you it's fine to use either one. So I'm going to do y minus -6 is equal to 2/3 times x minus 5. Okay, so I get y plus 6 is equal to 2/3 x minus 3 does not go into 5, so I'm going to do 2 times 5, so that gives me 10/3. So I need to turn 6 into thirds to make this work. So that's going to be 18/3. So I'm going to do y plus 18/3 is equal to 2/3 x minus 10/3, and I'll subtract 18/3 from both sides. And I get y is equal to 2/3 x minus 28/3. And that does not divide evenly, so I'm just going to leave it alone.